Hi again. I'd like to talk a little bit more about subsurface scattering and creating a subsurface scattering node inside of Lightwave Nodal. So let's just get on with it. As you see here, we have our dinosaur model, or our wannabe dinosaur model, and we're going to show the surface for this, which is a nodal, fairly simplified from the previous version. We took out the ray tracing part for one thing. We took out the depth part of that ray traces the depth of the dinosaur. This time we're going to do something that's sort of a little more like just the shading part of that without the ray tracing by taking that bent normal that we talked about and combining it with just a regular Lambert shader. So let me turn off the bent normal for now, and we'll just see how it looks. Okay, I've just unconnected that, and as you see, it looks just like light wave shading with some Phong instead of the blend specularity is the only difference here. We've got a Phong shader in there that we just added to our surface. So basically all that is right now is a Lambert shader and a Phong, and it's being added into a material which goes out to the material output. So that's not really mysterious. Let me turn that part off now and plug in the other part. I'll unplug the Lambert shader there and take this bent normal Lambert shader we have and plug that in. Oops, unplug that in. And here you see we have a little bit more of a what looks like a subsurface scattering, but it isn't really subsurface scattering. It just sort of looks like it. It is effectively similar to subsurface scattering because of the way we're bending the normals to face towards the light. It's as if our surface was always facing towards the light, even though it's in reality is not. But our surface thinks it is. So this has the effect of simulating the effect of minute cells and other things reflecting light back towards our light, even though the surface on average is not facing towards the light. And had light been shot off in some other direction where there isn't a light, well, that wouldn't contribute to our surface lighting anyway, so it averages out to be still a somewhat accurate subsurface solution, if you're thinking about it that way. So let me just go over this again. As you remember, we have a bent normal to object node that is part of the library that I put on the it's on the NewTek list on the NewTek website under their forums, under a thread called nodes, or several nodes, or some nodes, I forget exactly. Basically what this does is it takes the surface normals and bends them towards the light source, or towards a particular object actually. So here's an item info. You see that's our light 1. And we just have a few other attributes we have to plug into it: a world spot, a normal, and a reference world position, which is the position of the light. And also a value, which we use a scalar. And for this case, we use 0.5 as a value. 0.5 is a pretty good value. If we use 0, we would just get a normal, a normal. And if we use 1, the normal would be bent 100% to the light. So 0.5 is a pretty good starting place for that. And as you see, if I move the light behind the object, technically our object would be almost completely dark because the light would be facing away. But because of these bent normals, or the little the normals facing out from the surface are now being bent towards that light, we are actually seeing some of the light still on the surface, even though the light is completely 100% behind our object. So it's a good kind of a fast way to do this. It's calculated very quickly. There's no ray tracing or anything fancy going on. So it's a good compromise. One other thing we did is, instead of using the normal of the surface, we use the smooth normal, which means it's basically the object geometry that has been smooth, but it has not had the bump map or any of that other stuff applied to it. It's just the smooth surface of the object. We did that because had this been a subsurface, had this light been reflecting off the surface of the inside of our object, well, there really wouldn't be all that bump stuff. It would just be like the inside of the dinosaur. It wouldn't have all these bumps on it. So we wanted to do away with those bumps. So we just used the smooth normal instead of the actual surface normal, which would have had all the bump mapping and everything on it. Smooth normal doesn't have any of the bump mapping or anything. So we plug that into our bend normal to object. We plug that normal into our Lambert shader, which is just a normal light wave shader. It's under the shaders tab on Nodo here on the sidebar, and we output the color from that into an add vector, an add vector, and we output that to a make material, and that gets output to our final output. Alright, so the only thing we have to do after that is go ahead and add a regular Lambert shader that will be sort of a will actually reflect the light from the outside of our surface instead of the inside of our surface, and that will have all the bumps and everything on it. So I'll go ahead and plug that in. As you see, the normal is coming right from there, it's going into here, and the color from that shader, that Lambert shader, is going into the second add. So we're adding one to the other. We're adding a regular Lambert shader with our bent normal Lambert shader. So as you see, as we move the light to the front, you see all these nice bumps and everything and all this specularity, all that stuff. But when we move the light to the back, you don't see any bumps, you don't see any specularity. You're just seeing light as if it were passing through the object. In fact, had we made this a more of a red surface, let me see, I think I have a gradient that is defining that color. I have that happens to be set to incidence. Had this been a red color, it would look somewhat like our dinosaur. The inside of our dinosaur was red. There we go, as you see there. In fact, it might be better to have the green on the outside and the red on the inside. Let me try that. Let's see, invert this. There we go. Let's see. Well, good enough. Actually, that should be a little brighter and that should be a little darker, so let's modify those somewhat. It's darker because it's denser on the inside of the dinosaur than on the outside. That should be a little bit brighter. Let's see. Anyways, there you go. That is one simplified way to do subsurface scattering in Lightwave Nodal. Hope this has been informative. Hope you enjoyed watching the tutorials. I'm pretty much on my last day of my trial for Lightwave. I have an old 9 license, but I do not have the most current one, so maybe the last one for a while until that situation gets sorted out. So thanks for watching. Keep an eye on PD Howler at thebest3d.com and squirreldome.com, my personal website, because we'll be releasing in the next few days, and it'll be very exciting and cool. And hope it's all been fun watching these tutorials over the last few weeks. Hope I've made good use of the last 30 days. Let's see, we did a path tracing, we did we solved the bunny ear problem, and etc. So thanks again, and TTFN.